So in this video, I'm going to do some examples of applying those congruence theorems and the congruent statements to different diagrams. So it says identify which congruence theorem applies to each, then write a congruent statement. So I'm trying to say, why are these two pairs of triangles congruent? And one of the theorem has to either be side, 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 angle, side, angle, angle, side, angle, side, angle, or hypotenuse leg. So it has to be one of those. If it is not one of these, then we say there's like not enough information to prove them congruent. Again, the diagrams are mostly going to look like they're congruent. So you need to go based on the markings and not looks. And so if I look at this first one, I can see I have tick marks and I have like A, B, and EF having each one tick mark. So that side is congruent. So this is like one side. I have AC is congruent to DF. So that's the second side. And I have BC is congruent to D, again, because of the tick marks. So this one usually is the easiest one to see. This is side, side, side. So these are congruent by side, side, side. And the congruent statement is writing like triangle blank, blank, blank is congruent to triangle blank, blank, blank. And I have to match them up. So the first triangle, do whatever order you want. I'm just going to do alphabetical order. And then second triangle, I'm going to match it up. So A is between 1 and 2 tick marks. So I'm going to go to this diagram and find the one that is between 1 and 2 tick marks, which is F. Okay. B is between 1 and 3. So I'm going to go and find between 1 and 3, which is E. And then that means C would have to go with D. And again, it's between 3 and 2, and so is D. Okay, and so it's very important that you pay attention, take your time, and make sure that the corresponding parts are matching up, which means the corresponding sides, the ones with the same number of tick marks, are in the same order in the statement. Okay. So for number 2, I want to say, okay, do one of these 5 theorems fit this? And so if I look, I have angle B is congruent to angle X or angle Z because they both have 1. So you can pick one, it doesn't matter. And I have another angle C and Z. And then I have a side BC and XC. And I have to be careful because I have 2 angles and a side. So it could be angle, angle, side, or it could be angle, side, angle. And so what you want to look at is that side directly between the 2 angles? Is it called an included side? It's included between those 2 angles. And that means that side touches both of those angles, which is true on both triangles. So this one is angle, side, angle, angle, side, angle. And again, the markings have to match up on the 2 triangles. And then I'm going to write the congruent statement. So A, B, C is congruent to triangle. And this one, they match up the direction, so it's a little bit easier. But Y and A both don't have a mark. B and X both have 1, and C and Z also both have 1. Okay. You could also, for this one, because of the markings that are the same for the angles, another congruent statement with this one would be Y, Z, X. Because you can say angle B goes with X or angle B goes with C, since it's going to be an isosceles triangle with 2 congruent angles. Okay, so we're going to, again, look at these 3, and our theorems are angle, side, angle, side, 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 angle, side, angle, angle, side, and hypotenuse leg. Those are again, the 5 that work. Just remember angle, angle, or angle, 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 and side, side, angle, or angle, side, side do not work. Okay? So these are a little bit trickier. One thing is if there is a shared side on the 2 triangles, that side is considered congruent for the 2 triangles. So this side counts for both triangles. And for some students, it helps to redraw the triangles if you need to. So H, E, G, and I would do, this is at 1 mark, that's that angle mark, and then 2 marks. And then I would have this other triangle, G, F, E. And this has 1 mark, G on this one has the angle, and then these 2 tick marks to indicate that shared side. So for some students, rewriting it helps. Others, you can see it right from here. Either way is fine. But for these 2 triangles, I have the 1 tick mark side, so that's again a side. I have the 2 tick marks, which is a side, and I have this angle. And that angle is the included angle because it's directly between the 2 sides. So this one would be side, angle, side. And it's going to be triangle EHG is congruent to triangle. Okay. So this is where I have to be careful. Let me just get rid of that A because that makes it a little bit confusing when I'm trying to write my similarity statement. Okay, so E has this 1 mark here. And so E on this triangle goes with G on the other triangle because that has that 1 mark. Right? So it might not be that E always goes with E, it just kind of depends how the triangles line up. Then H is between 1 tick mark and none. So if I look, 1 tick mark and none is F, so then it's F. And then G is between 2 and none, which is E. And so this is my congruent statement. Okay, so often, sometimes the same letter is not in the same position in the 2 statements. My 2 triangles, one thing I noticed is I have right angles. And anytime you have right angles, check if it's HL. It doesn't have to be, but check. Any shared side, so this AC is on both triangles, that I can mark as congruent. And again, I have this 1 triangle ADC. So I could, again, redraw that. And I'm going to mark this. And then I have that other triangle. This way. A, B, C, and they have marked BC the right angle, and then again, AC is a shared side, so those are congruent. So if I look at those, either the regular diagram or this one, I can say I have a right angle, and I have a hypotenuse, and a hypotenuse. I have a leg and a leg. And so this is hypotenuse leg, and I would have triangle ADC is congruent to triangle. Okay, so A is between 1 tick mark and 2 between the hypotenuse and that congruent leg, and that's where C is. So that's going to come first. D is the right angle, so that goes with B. And then this C is going to go with A. And again, A in this first statement is first, but in that second part of the statement is last, because in this case, this angle A is going with this angle C. So those are the congruent parts. And so this is HL. And then the last one for this video we're going to look at is this one. So again, I have AB to DE. So I have a side. And then I have B and D. So I have an angle. And then I have this C and this C, which is again another angle. So I have two pairs of angles and a side. And again, I have to be careful about, is that angle, side, angle, or angle, angle, side? And if I look, the side is not between the two angles. So again, when I say between or included, I mean it's like the side that touches those two congruent, those two angles that are marked congruent to the other two angles in the triangle. So this one is going to be angle, angle side. I have two angles and a non-included side. And I would say triangle ABC is congruent to triangle, and this one's a little bit easier to match up. A goes with E, B goes with D, and C goes with itself this time. So that's a few examples of how to apply the congruence theorems.